Hello children, a warm welcome to you all. From our previous sessions, you have learned about various ways of describing the motion of objects and causes of motion. Another concept that helps us understand and interpret many natural phenomena is work. Closely related to work and energy and power. In performing our day-to-day activities, we use words like work, energy and power, which are closely related. Sometimes we use these words without actually paying much attention to them. In daily life, people carry out various tasks like carrying weights, cleaning, cooking, watering plants in the garden, etc. Similarly, you employ machines in our homes to carry out different tasks. How are these works being done? What do you need to do these works? Both human beings and machines need energy to do work. Generally, this energy is derived by human beings from the food they eat and for machines through the electricity supplied to them. We notice that a person or machine doing any work spends some energy to do work. Where does this spent energy go ultimately? Is there any transfer of energy while a work is being done? Can we do any work without the transfer of energy? In this chapter, you will examine these concepts more carefully. I am Shubhajit, and today interpreting with me is Hemalata. We are here to explain to you about work done from the lesson Work, Energy and Power of Class 9 Physics in this session. Learning outcomes. At the end of this session, you will be able to understand about work, scientific meaning of work, definition of work in science. Keywords: work, work done, force, displacement, the change in position of an object. Before starting the session, let us look at the concept map of this session. In our daily life, we use the term work in various situations. The word work takes on different meanings depending on the situation. The statements like, I am working in a factory, the Ramayana is a great work of Valmiki, the machine is in working condition, there are a large number of worked out problems in this book. Let us work out a plan for next year, etc. There is a difference between the way we use the term work in our day-to-day life and the way we use it in science. Let us consider a situation where a person is preparing for examinations. She spends a lot of time in studies. She reads books, draws diagrams, organizes her thoughts, collects question papers, attends special classes, discusses problems with her friends, perform experiments, etc. In our common view, she is working hard. But if we go by the scientific definition of work, the above mentioned activities are not considered work. Let us consider another example where a person is working hard to push a huge rock. Let us say the rock does not move despite all efforts by him. He gets completely exhausted and tired. According to our common view, he worked hard, but as per science, he has not done any work on the rock. In another example, let us assume you climb up the staircase and reach the second floor of a building. You spend some energy to do this. In our common understanding, you are not doing any work, but as per science, you have done a lot of work to reach the second floor of the building. In our daily life, we consider any useful physical or mental labor as work. But according to the scientific definition of work, not all of these activities are considered as work, and only a few of them are considered as work. What is work? Why is there a difference between the general view of work and the scientific view of work? To understand the way we view and define work from the scientific point of view, let us consider some situations. Push a stone lying on a surface. The stone moves through a distance. You exerted a force on the stone and the stone got displaced. In this situation, work is done. A girl pulls a trolley and the trolley moves through a distance. The girl has exerted a force on the trolley and it is displaced. Therefore, work is done. Lift a book through a height. To do this, you must apply a force. The book rises up. There is a force applied to the book and the book has moved. Hence, work is done. A closer look at the above situations reveals that two conditions need to be satisfied for work to be done. First, a force should act on an object. And point number 2, the object must be displaced. If any one of the above conditions does not exist, work is not done. This is the way we view work from the point of view of science. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Work done equals to force into displacement. W equals to force into S. Thus, work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work has only magnitude and no direction. So, work is a scalar quantity. We measure force F in newtons N and displacement S in meters M. In equation W equals to F into S. If F equals to 1 and S equals to 1, then work done by the force will be 1 Newton meter. Hence, the unit of work is Newton meter bracket Nm or joule J. Thus, 1 joule J is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. What would be the work done when the force on the object is 0? What would be the work done when the displacement of the object is 0? If the force or displacement is 0, the work done is 0 because it did satisfy the condition for the work to be done. Consider a situation in which the force and the displacement are in the same direction. A baby pulling a toy car parallel to the ground. The baby has exerted a force in the direction of displacement of the car. In this situation, the work done will be equal to the product of the force and displacement. In such cases, the work done by the force is taken as positive. There are certain cases where the displacement of the object may be in a direction opposite to the force acting on it. Consider a situation in which an object is moving with a uniform velocity along a particular direction. Now, a retarding force F is applied in the opposite direction. The object stops after displacement S. In such a situation, the work done by the force F is taken as negative and denoted by the minus sign. The work done by the force is F into minus S or minus F into S. Work done is negative when the force acts opposite to the direction of displacement and the body on which work has been done loses energy. Work done is positive when the force is in the direction of displacement and the body on which work has been done would gain energy. Points to remember. The work done by a force acting on an object is equal to the magnitude of the force F multiplied by the distance moved S. The unit of work is joule. Work done on an object by a force would be 0 if the displacement of the object is 0. Work has only magnitude and no direction. So, work is a scalar quantity. If the force acting on an object and displacement are in opposite directions, then the work done by the force is taken as negative. If work has a positive value, the body on which work has been done would gain energy. If work has a negative value, the body on which work has been done loses energy.